Alright, hello everyone, welcome to this channel. We are now in Chapter 3, Hardware of IGCSE Computer Science. And in this video, we are going to learn about what a CPU is and what it does, and also the monument architecture. So, the CPU is central to our modern computer system. One misconception about CPU is that people always thought that CPU is the desktop and laptop that we use on a day-to-day basis. But in reality, it's just a chip on the computer itself. And its responsibility is to carry out and process all the instruction and data in a computer application. So, what are instructions? Let me give you an example. So here we have a snapshot of the game Valorant, and when we shoot a bullet using the gun, there are actually multiple instructions that is happening behind the hood in the computer. So the first instruction, it could be the reduction of your bullet in your gun. Alright, and it could also be the reduction of your enemy's health when you hit the target. So these are all the instructions that needs to be carried out by a CPU. And how the computer often work with a CPU is via this architecture called the monument architecture, in which it consists of multiple components. So if you look at the star here, first of all, the CPU is part of the monument architecture, the first one, and also the memory unit, our RAM, followed by input and output, the devices where we give the computer an input and also an output, how the output is shown. And in this video, we are going to go through each component in a very brief way to show you what they do and how they work together to help a computer to carry out an instruction. And let's move on. So let's look at them one by one. The first component that we are going to look into is the ALU, which we call the arithmetic and logic unit. As implied by the name, it carries out arithmetic operations such as adding, subtracting, multiplying, and dividing. And it also carried out logical operation, which helps the computer to make certain decisions. And here there's a note here, which is it's possible for a computer to have more than one ALU. So in a CPU chip, there could be more than one ALU in which each ALU will carry out a very specific task. So for instance, one could be doing the addition, subtraction part. The other could be doing the multiplication and the division part. So how it works here, I have included some drawing here. And it often takes multiple inputs from the RAM and produces an output. So that's ALU. And the second component in the monument architecture is the memory unit, which is the RAM, in which it is just a storage box that stores all the instructions that the CPU needs to access. Okay, and how the CPU obtains all this instruction is that it first takes data and programs held in a hard disk drive and put them into our RAM. So if you are in a video editing software, what the CPU does is that it will take the codes from the hard disk and move it to the RAM so that the CPU can access it. And the reason this is needed is because the read and write operation carried out using the RAM are considerably faster than those in a hard disk drive. This is why the CPU needs to move all this data from the hard disk to the RAM so that it can access it faster. And another note about RAM is that it is a type of volatile memories in which its content will not be retained after the computer is shut off. So an example that I can think of is that when you are playing a game, if you don't save your progress and you power off the computer, the progress will not be in your permanent memory, will not be in your hard disk. The progress is all gone because RAM is where your computer will save your progress. But after you save your game, after you save your progress, all this data will be moved from the RAM into the permanent memory. That's how the RAM works. Is a type of volatile memory. So, having talked about the RAM, another components that we're going to talk about is the registers. The 5 registers which we will learn. In reality, there are more than that, but in our course, we are just going to look into the 5 registers. And here they said that the registers are one of the most fundamental components of a monument architecture. It means that without them, the CPU wouldn't be able to work. And One thing about register is that it's very similar to what RAM does. It also stores instruction, in which each register they store different part of the instruction. And let's look into it. The current instruction register, CRR, the first one, as implied by the name, it stores the current instruction being decoded and executed. And the second register is the accumulator. It is used to store the result of the ALU calculation. If you remember, the ALU will produce an output, and the result of this output will be stored into the accumulator. And next up, the memory address register. It is used to store the address of the memory location currently being read and write to. And as for the memory data, it stores data which is needed to be stored. And last but not least, the program counter. It stores the address where the next instruction to be read can be found. And at this point of time, you might find it hard to understand why are all these registers needed. But as we go through the Fetch-Decode-Execute cycle in the next video, you are going to see how these components work together to help a CPU carry out a task. Alright, so these are the 5 registers. And next up, we have the control unit, which is also located inside the CPU. As the control unit controls all the operations in a CPU. I like to think of it as control unit as the boss of all the components, because what it does is that it reads an instruction, and the address of the location can be found is stored in the program counter. And this instruction is then interpreted during the Fetch-Decode-Execute cycle. And what control unit does is that, in third point, it sends signals along the control bus to all the components so that other components know what to do. So it's basically the coordinator of all the instructions that need to be carried out. So the control unit is here, they say, is responsible for making sure all these components follow the instruction it has processed from the input. So that's control unit, the big boss of the CPU. And we also have the bus, if you look here. Here we have go through the multiple components of a CPU, but how do they really communicate, right? And the way that you do this is via the buses. We have 3 types of buses, which is known as the address bus, the data bus, and the control bus. All these buses, they are like the connection here, in which they carry data around a computer. So it's just that each bus, they carries different types of data. For the address bus, it carries the address between the memory unit here, from the memory unit back to the CPU. And as for the data bus, it carries the data from the memory unit and the CPU. And the control bus, it carries a signal from the control unit to all the other computer components. And one note about all these buses is that the width of the buses are important. The wider the bus, the larger the word length. In other words, the more data it can carry. So having learned about all these components of a von-Neumann architecture, I hope that you will understand all the elements that are in the CPU. So what we learned is that there are multiple components in a CPU, such as the ALU, first one, the control unit, and all the buses, and followed by the registers. And apart from the CPU, the memory unit here, they are also part of von-Neumann architecture, input and output. So here we can conclude the entire video. So in this video, we learned about all the components of a CPU and also all the elements in a von-Neumann architecture. And in the next video, we are going to see how all these components and elements work together to help a CPU process an instruction. I'll see you in the next video. Goodbye. Alright, hello everyone, welcome back to this channel. And in the last video, we learned about all the components of a CPU and how all the elements of a von-Neumann architecture work together. So in this video, we are going to go into the Fetch-Decode-Execute cycle, in which it is a method of processing data that the von-Neumann architecture uses. And this cycle usually happens very quickly in a matter of milliseconds, which means that there can be billions of cycles happening in just 1 second. And all the components inside the CPU will involve in this operation. So for simplicity's sake, I transformed this diagram into the simpler one, in which the central processing unit is on the left and a more detailed version of the memory unit is on our right. And how do we read this memory unit diagram is that the right hand side of the memory unit is the address of the memory unit, and in each address there will be data stored here. Okay, so just some side notes here. All of these values, the address and the data, will actually be stored using machine code, which is 0 and 1. But for explanation purpose, I put it as a binary form so that you can understand what I'm saying here. So these are the 6 steps of the Fetch-Decode-Execute cycle. It's pretty lengthy, and therefore we are going to go through each step by visualizing it using a diagram. So imagine that this is the instruction that we want our computer to carry out, instruction. And let's look at how many cycles that we need to carry out this instruction, even though we know that the answer is 5. How will the computer do this? So first of all, if you look at the memory unit, we have the value 2 and 3 located in our memory unit. Alright, so let's see how they are being added together. So first step, the program counter stores the address location of the next instruction to be carried out. So the first instruction is 101, so we just have to look into what is inside our 101 location, which is this instruction, load 10. And this location number 101 will then be copied into our memory address registers. So that's what they are saying here in our first step. Step number 2, this program counter is incremented by 1. So from 101 incremented to 102, so that the computer will know what is the next instruction that needs to be carried out after load 10 is being carried out. Okay, so step number 3, at this point we already know what is the instruction that we need to carry out, which is 101, and the control unit will then make a request to the RAM for the instruction and obtain the address of the location from the MAR by sending a signal, which means control unit will now get the address from the memory address register, which is 101, from the memory address register. Okay, and the fourth step is that the data that is being held in the RAM in the correct address is carried. The control unit will then ask the memory unit to send whatever that is in 101 to the memory data register, which is used to store the data, load 10. And once the instruction arrives at MVR, it is copied into the current instruction registers, in which we can see it here. And current instruction register is basically stores the instruction carried out by at that time, and the instruction is then decoded in CIR using the arithmetic logic unit. The result of this processing is stored in the accumulator. And the word load 10 here, it doesn't mean I want to load the value 10. In fact, it is saying that I want to load whatever that is inside location 10. I want to load the value into our accumulator. So as you can see from the right hand side, at location 10 the value is 2, and therefore this value 2 will be stored, will first be moved to the memory data register, and then it will be stored into our accumulator. And that's the end of our first instruction. All we have done is just we load the value 2 into our accumulator. So next instruction is that, okay, again, it's the same step, it's just another cycle. The program counter now will store what the instruction that we need to carry out, which is 102, and this 102 will be copied into the MAR, memory address register, and the program counter will then be incremented by 1 from 102 to 103, and the control unit blah blah blah, it will make a request so that it knows what instruction to be carried out. In the fourth step, this instruction from address 102 is moved to the memory data register, and the next step, this instruction will be carried out, copied into current instruction register, and the control unit will do its task. So this instruction at 11, again, we are not adding the value 11, we are adding whatever that is inside location 11 in the memory unit. So the ALU will then carry out what is being required, 2 plus 3, and the result of this processing is stored in the accumulator. So the result of the ALU will store into the accumulator. So, but we haven't really recalculated the value, but the value is still not stored in our memory unit yet. So we need to do another cycle, the third cycle. Again, the same thing, this memory address register, they are the same, which carried out what is the address of the instruction that I need to carry out now. And program counter incremented by 1, the control unit make a request to the RAM for the instruction and obtain whatever that is inside the MAR, okay? And this instruction will then be moved to the memory data register, and the instruction will then copy again. You can see that it's repeated, the action is repeated. Store 12 is being put into CIR, and then the instruction is decoded and carried out. So this store 12, again, what they are saying here is that we want to store the result of our computation here, 5, into location 12. So take a look at location 12. It's now being storing the value 5, which is our result. So that's all we have done, 3 plus 3, and we put the result to location 12. And can you see that there are so many instructions involved for just one mathematical operation. So this is the instruction part of it. So this is essentially fetch, decode, execute cycle. Firstly, all the data that's needed will be fetched from the memory unit to the CPU, and then these instructions will be decoded inside the CPU and be executed. And this is the essence of fetch, decode, execute cycle. And now in the next video, we are going to talk about what are some of the factors that affect how fast the computer can carry out all this instruction. I'll see you then. Goodbye. Alright, hello everyone. In this video, we are going to look into the factors affecting the computer speed. And in the last video, we learned that fetch, decode, execute cycle is a very lengthy process. However, computer is fast enough to carry out billions and billions of cycles in just 1 second. And there are a few factors which affect how fast the computer carries out all this cycle. And we are going to look into the 3 factors. First one is the clock speed, the cache memory, and also the cores. Alright, so let's look at the clock speed. Clock speed is an important measure in terms of CPU performance capability. It basically refers to the number of electrical pulses that the clock inside the CPU can produce every second. And basically, clock speed is just the quantity, the number of cycles that a computer can carry out in 1 second. And by increasing the clock speed, the processing speed of the computer is also increased. So an example is that if your computer has a speed of 3.5 gigahertz, this means in 1 second, your CPU will be able to process 3.5 billion instructions. And by increasing the clock speed, your computer can carry out more instructions in just 1 second. And one term we need to look into is called the overclocking, in which the computer uses a clock speed higher than the computer was designed for. And the problem of this is that it will lead to seriously unsynchronized operations, which means an instruction is unable to complete in time before the next one is to be executed. This would cause the computer to crash. And the other problem of this is that overheating of the CPU will happen. So here are some of the disadvantages of overclocking your computer. And the next factors that will affect your computer speed is the number of cores that you use in your computer. We often hear that a CPU has quad core, dual core, and what do they really mean, right? It basically means that a CPU has multiple cores, and which means they will have multiple ALU, multiple registers. And the idea of using more core elevates the need to continually increase clock speed. What do I mean here? So imagine that this is a 1-core CPU, which we just learned, And having a multi-core CPU, it basically means that we just have two sets of CPU here. And that means two instructions can be carried out simultaneously because we are currently having two CPU cores. And one side note here is that oftentimes doubling the number of cores will not guarantee a double in speed, because we need to take into account the communication time in which these communications are needed so that both CPUs can be in sync. And the multi-cores, 8 cores, is a similar pattern. It just means that we have multiple core CPU in our CPU. So that's the two factors. First one is clock speed, but however we know that we can't overclock very often, and therefore computer scientists have come up with a way to put multiple core within the CPU. And the third method that we can increase our CPU performance is to use cache memories in our CPU. And unlike RAM, which is located outside the CPU, this cache memory is located within the CPU itself, which means that if the CPU has some information to access, instead of accessing it from the RAM, it can access from the cache, in which it will be faster because it is located within the CPU. And what the cache memory usually will store instructions and data that will be accessed often. Okay, so in point number 4, it says that if a CPU wishes to read the memory, it will first check whether the cache has that instruction before accessing the RAM. And the larger the cache memory size, the better the CPU performance is. And for you to visualize, the cache memory is basically just one mini RAM that is located inside a CPU chip. So so far we have learned the 3 methods of increasing our CPU speed. The first one is to overclock it, to increase the clock speed. And the second method is to use multiple cores in our CPU, multiple cores. And the third method is to include cache memories in our CPU. So that's the 3 factors that affect the CPU speed. Thank you, everyone. Alright, hello everyone, welcome to this channel. So in this video, we are going to look into what are instruction set and embedded system. So for instruction set, it's basically a common set of instructions that have been developed by processor manufacturers so that CPU can operate as efficiently as possible. So this instruction set basically consists of a set of instructions that the computer will use in a very frequent manner. And so let's look into what we did in the Fetch-Decode-Execute cycle. If you remember, we have our CPU here and also our memory unit here. And when we are doing the Fetch-Decode-Execute cycle, we have something inside the memory unit called the instructions. So the instruction set is basically a collection of all these common instructions that will be used by a computer. So let's study them in a more detailed manner. So these are the 3 instructions that we learned, and there are basically 2 parts for this instruction. The first part is called the opcode, and the second part is called the operands. As for the opcodes, it's basically a shortcut way of saying operational code. It gives the computer a precise job that is required to happen, and they are usually in the form of verbs. Okay, they are verbs. So these opcodes are stored on the computer hard disk and will be copied into memory RAM whenever they are needed. Remember that the computer can access the RAM memory faster as compared to the hard disk. And the most regularly used opcodes will be stored in the cache itself because it's even faster for computer to access the cache. And that's the opcode. They basically are the verbs of an instruction. The verbs, for instance, load, that means you load a value, add, you add value, store, you store something into the memory unit. And the second part of the instruction is the operands. All right, these operands, they can be either the address, So for our case here, load 10 doesn't mean that you are loading the value 10, but you are loading the instruction that is stored in the location 10. And it could also be a data. For instance, load 10, it can be a value of 10. Alright, so instruction set is, in essence, is basically a set of all the instructions that a computer will need. And let's move on to embedded system. So traditionally, we would think that computers are like the desktop and laptops that we use on a day-to-day basis. And these are called the general purpose computers because they can do a lot of things. You can play music, game, and even surf the internet in this computer. Therefore, it's a very general computer. So, however, for embedded system, it is also a type of computer, but in contrast to general computer, they carried out more specific tasks and jobs. And how they do it is that they embed a computer chip into a device to carry out function in a more effective way. In other words, what they say here is a combination of hardware and software, which is designed to carry out a specific sets of function. And the keyword here is that specific. Embedded system carries out very specific tasks. Here's some general ideas of what it consists of. What an embedded system consists of. It usually have an analog or digital input, and to take that input, they will certainly need a user interface. And after the data is being processed, it produces some types of output. And here are some examples. The first one is vending machine. All right, it has some sort of input to take in money. It also has a user interface, and after it processes the data, it will output the object that the user has purchased. Okay. Another thing could be lighting system, and they can take input in the form of detecting the temperature, the light sources, and open the suitable light. And here are some information about embedded system, in which some of them they are all low power devices. They don't need a lot of electricity. And the second point of the embedded system is that some are programmable, and which means you can customize the computer system to suit your need. However, some are not non-programmable, in general, to be replaced if they require software update. Alright, so programmer device requires upgrade by two methods. If you want to program the embedded system, you are either connect your device to a computer, or you download a software update, or you can automatic updates via a Wi-Fi, satellite, or cellular. So that's all about embedded system. It's basically a specific types of computer that carries a very specific task, alright, unlike the computer that we use. And so that's the end of it about instruction set and also embedded system. I'll see you in the next video. Goodbye. So hello everyone, welcome back to this channel again, and in this video we are going to learn about the multiple input devices that a computer would need. So just a recap on the von Neumann architecture, we have the central processing unit, RAM, and also input and output device. And our focus for this video is the input devices that a computer would need. Think about it, without input devices, our computer would probably work on autopilot, in which we can't really communicate with it, we can't really do the stuff that we would want. Therefore, input devices are extremely important to make computer useful to a lot of us. And we are going to go through input devices one by one and study what they do and how they work internally. So the first input device that we're going to go into is the keyboard. We all know what keyboard is. It allows us to type in letters and numbers into computer, and they are connected either using a USB port or wirelessly using a Bluetooth connection. Alright, so there are other types of keyboard that we use on a day-to-day basis. This is called numpad, and digital keyboard that is on our phone is also one, and also the most recently announced Magic Keyboard from Apple. These are all keyboards, but just that they are in a different manner. So it is a type of input device because it allows us to send data to the computer. And how it works internally is that whenever we type a character on the keyboard, it can be any types of keyboard, this action will translate into the binary understood by computer, and it will then be sent to the central processing unit to be processed. That's how computer process input data. Every action that we do to our input devices will be converted into binary and then processed by the CPU. So besides the keyboard, we also have the mouse. Very simple. It's left and right button. It's often used as a pointing device. Basically helps us to point into a place where we want to be. Again, similar to a keyboard, it's connected using USB or Bluetooth. And here is some information of how it works internally. It basically, for your mouse, a red LED light is used at the base of the mouse. So I have a mouse here. Your mouse would have this thing too. So basically, when if I were to turn this off, it will turn red, and the red light is used for reflection. So what they say is that red light will be bounced off the surface, and the reflection will be picked up by a CMOS, which is a type of materials used. And this CMOS will generate electric pulses to represent the reflected red light, and these pulses are sent to a digital signal processor. And by using the reflection of the light, what they say here is that the processor can work out the coordinates of where we are pointing to using our computer. And then the computer will then move the cursor to the coordinates sent by the mouse. Remember this? It happens in a millisecond. Just like Fetch-Decode-Execute cycles, all these things happen very quickly. That's how they ensure that you are moving in real time. Your movement can be shown in real time on your monitor. Okay, so there are other types of pointing devices. Besides the mouse, it could also be a gaming controller, touchpad on your laptop, or even a stylus, which I'm using now on my iPad. So the next input devices is also your touch screen, which is more common in our smartphones today. They react to a finger press. That allows the user to carry out the same function as they would be with a pointing device. So instead, I think Steve Jobs once said, instead of having all this different gadget as your pointing device, you are using your finger as your pointing device. So that's how touch screen works. So in our subject here, we are going to learn 3 types of touch screen, in which each touch screen has some advantages and disadvantages. The first one is the capacitive touch screen. They are usually used in our phones. They have better image clarity, and they support multi-touch, in which this type of touchscreen can work by having, even if you put 2 fingers, they will be able to react to 2 fingers movement simultaneously. Alright, here are some of the information of how it works internally. You can read it, and its disadvantage is that it's more expensive to manufacture. So that's capacitive, and we have another type of touchscreen called a resistive. It basically works by calculating the amount of downward pressure applied to the screen, and then based on the pressure, they detect the coordinates of where the pressure change has happened. The advantage of this type of screen is that it can be used in bare finger, stylus, or even glove hand, which means it's very versatile. And its disadvantage is that it has lower touch sensitivity and no multi-touch. They are basically used in shopping mall where we need to check for directory, the type of screen. Alright, so that's resistive touch screen. And last but not least is the infrared touch screen. It's the most sensitive touch screen among the 3. It works by emitting a grid of light, and when this light grid is interrupted, the touch on causes a disturbance, and the disturbance is then translated into a coordinates in which the screen will react to. And because it's very sensitive, one of the disadvantages is that it's very susceptible to false touch. So these are the 3 types of touch screen: capacitive, resistive, and infrared. Each has their own advantage and disadvantage. You will need to memorize them just in case they ask you in your exam. So the 4th input device that we're learning is the scanner, in which they convert text or images on paper into digital format. Alright, so how it works is that you can just place a paper on the scanner, and then the content of the paper will be translated into digital forms such as PDF or Word document. And the information, alright, all this, how it works is that the light will reflect onto the paper and determine what are the colors and the image, and this information is then used by the computer to produce the document. And in the scanner, there's this technology called the optical character recognition, and OCR is basically used by a computer to scan text from document and convert into text file format. This technology is useful because they can translate it into the format which you can change the text. If you were to scan a text called ABCD, they will translate it into a document which contains the word ABCD, and at the same time you will be able to change whatever that is on that document. Alright? So, if the original document was a photograph or image, then the scanned image will form an image file such as the JPEG. So besides 2D scanner is used for paper. A 3D scanner is then used to scan a 3D objects, and then all the reflections, all the scanning will be translated into a model to be shown. So that here are some of the application. That for 2D scanner is used in the airport to read the passport, so that with the OCR technologies, the image like your photos or your informations, then it can be manipulated and stored into their database. Alright, and as for the 3D image scanner, they are usually used by designers to create prototype by scanning just the object and then translate it into a computer to be manipulated. So these are scanner. Another type of input device is the barcode scanner, which are usually used in a shop, and they use infrared light to read the bars, right, in the code. And what it does is that it accesses information about a product within a store. So this is a barcode here, and in this part we'll learn how to read that. So each barcode actually stores information about like product identification number, country of origin, and manufacturer. Alright? Okay, so what it does is that we have a barcode here, 543051, and how we read this is that by reading this part, the computer will know that this is the value 5 by checking out the table here, as you can see. Alright, they will basically split into the left hand part and the right hand part, and for the left hand side, this 5 here will be read from here, and 4, again they will cross check which shape it is, and that's how a computer read the barcode and translate it into numbers, and all these numbers will then be used to match the database record to check what is the price of the object, okay, of the product. So that's how barcode work. How they work is that basically they use an infrared light to read the bars in the code, and based on the light that is reflected, the data is determined. Alright. So another form of input device is the quick response scanner, which is the QR code, and instead of using a line like barcode, they use some boxes. It allows characters, what it does, allow characters, digit, and internet address to be encoded, so that the user will not have to remember every information. You can just scan and access the information. And here are some comparison of QR code and barcode. QR code can store more information, and they are easier to read. They don't need expensive laser or LED. Your phone will be able to do that. And it's also possible to encrypt QR code to give them greater protection. As for barcode, more than one QR format is available, and QR codes can be used to translate malicious code. Alright, so barcode is a lot safer because you can't store malicious codes out there. And the last two input device, such as digital camera, it is also an input device in which you take a digital image of the view in front of its lens. And how it works is that it captures lights using a light sensitive cell, and all these cells is made of tiny sensors which act as photodiodes. Alright, and these devices, these components, they convert lights into electricity, and all these images will then be viewed after being converted to digital converter to a digital image array, which are two-dimensional pixel array to be shown on our computer or monitor. And last but not least is the microphone. Instead of taking images like the webcam, microphones take in sound, and it's connected either using a USB port or Bluetooth. What it does is that it converts analog signals into digital signals. It's mainly used for web conferencing. And so imagine that this is the word that I'm saying, hut, and this sound will be picked up by the microphone, and be converted into binary value and then processed by the CPU. So these are all the input devices that we learned today. We never go into the details of it too much, but here are all the things that we need to know. We go through what is keyboard, mouse and how they work, touchscreen and the 3 types of touchscreen that are involved, scanner, 2D and 3D scanner, barcode reader, and also the QR code, digital camera and microphones. So that's the end of this video. Thank you for watching. See you. Alright, hello everyone, welcome to this channel. So in this video, we are going to learn what is a sensor and what are some of the applications. If you remember in our volume and architecture video, we introduced some of these elements here. So we have the CPU, the memory unit, the input and output. And think of sensors as an automatic input. If you think about it, for our normal sensor device such as mouse or keyboard, you will need human interference. But as for sensor, think of it as an automatic input device in which it can work itself by detecting what is happening before the surrounding and help the CPU to make the right decision. So here are the function of a sensor. It reads and measures physical properties from their surrounding, and the properties that they measure could be temperature, pressure, acidity level, or even length, etc. And before we proceed to knowing the different types of sensor around, we need to understand this component known as the analog to digital converter. And if you remember in our data representation video, computer can only understand binary, which is 0 and 1. Therefore, if a sensor were to give it a value of 39 degrees Celsius, for example, the computer wouldn't be able to understand it. Therefore, an ADC is needed to convert what is captured by the sensor into digital data like 0 and 1. And there's an extra note here in which you can see, beside ADC we also have DAC. For instance, if you want to convert the binary data back to analog signal, you have to use this component called as the digital to analog converter. And another term we need to understand is the term called feedback. We can read here, sensor readings may cause microprocessor to alter WAV or motor. This means that the sensors will sense something and then tell the CPU to control the WAV or motor and change the next reading taken by the sensor. And because of what is the action that's being taken, the reading that is received by the sensor will change. And the output from the microprocessor will impact on the next input received as it attempts to bring the system within the desired parameters. So let me show you an example of what a feedback is like. So for instance, here you have a system that controls the temperature of a room. And you will need a temperature sensor. And imagine that the value that it detects is 40 degrees Celsius. And this value, as I mentioned, it needs to be converted to binary using the analog to digital converter. And this value will be received by a microprocessor, and the microprocessor will then control the output by releasing cold air. And because of this action, the next reading that is taken by the thermometer will be different because of the cold air that we release. And this is called feedback, which means that after a sensor detects a value, it sends the signal to a microprocessor, and the microprocessor does something, and this something causes the input to be taken by the sensor to be different as compared to what is being taken prior to this. And this is called feedback, which is very useful when we are doing the essay question. Okay, so here are the different types of sensors that we will learn. Knowing these types of sensors is important so that you know what types of sensors should be used if you are given a scenario, this scenario, and so on. And the first one, we have our temperature sensor, like what we discussed. It basically measures the temperature of the surrounding, and it is used in a control heating system, chemical process, and also monitor temperature in the greenhouse. And the second sensor is the moisture sensors. It, as the name implies, it measures the water level, for example in a soil. It is also useful in a greenhouse and also the moisture level in the food processing factory. It ensures that the food is not too moisturized. And the third sensor, so we have the humidity sensor. It's a little bit different to moisture. Humidity measures the amount of water vapor in the air. Alright? Again, it's used in a factory manufacturing microchip to ensure that the air humidity is not very high. And also, again, the greenhouse is in again. And the fourth sensor that we learn is the light sensor, in which they use photoelectric cells to capture, produce an output depending on the brightness of a level, right? So that's how they tell the computer how bright it is and the surrounding. And followed by the infrared sensor. It is an invisible beam of infrared radiation picked by a detector. If the beam is broken, then there will be a change in the amount of infrared radiation reaching the detector. And some of the application is quite interesting. What they say here is that imagine this infrared radiation can turn on a car windscreen wipers when it detects rain on the windscreen. So the infrared radiation will be interrupted by the rain, the water droplets. It will also use in security alarm system. So the next sensor, we have the pressure sensor. It is produce and generate different electric currents depending on what is the pressure applied. And it is used in lorries and weighing station, and also measure the gas pressure in a nuclear reactor. For now, you don't really have to understand each sensor's application. I mean, don't have to memorize it. All you have to do is just understand what they do, so that when the exam question gives you a scenario, you know which sensors you should be using. So let's proceed to the next sensor, which is our sound sensors. It detects microphones that convert detected sound into electrical signals and pulses. It's very obvious. They pick up noises and then let the computers know that there's no noise there. And also we have the gas sensor. It basically there are two types, many types. Examples are the oxygen and carbon dioxide sensors. They use the various methods to detect gas being monitored and produce an output that vary with the carbon dioxide and oxygen level present. Okay, again, it is used in greenhouse. So the ninth sensor is the pH sensors, in which they measure the acidity through changes in voltages in, for example, soil. Again, it's used in greenhouse and also used in chemical process. And we also don't forget the magnetic field sensor. They measure the changes in magnetic fields, and the signal outputs will depend on how the magnetic field has changed shape. We won't go into details of how magnetic fields work because that's physics, but just remember that that is a sensor that can measure how much change there is in a magnetic field. Okay, and followed by the accelerometer sensor. They basically measure how much acceleration an object has, and they are used in cars to measure rapid deceleration and apply airbag when you are in a crash. It's also used by mobile phones to detect whether the phone is in landscape mode, it's in portrait mode, or landscape mode. And also the proximity sensor, they measure the presence of nearby object. So they, if you use the recent iPhone 11 or 12, you will notice that when you were to put your phone on your ear, the screen will turn black. That's the proximity sensors in action. And the last slide, we also have the flow sensors. It measures how fast liquid or gas is moving. That's why it's called flow sensors. It's used in respiratory devices and inhaler in hospital, and also measure gas flow in pipe. There's 14 sensors. The last one that we are going to learn is the level sensors, in which they use ultrasonic to measure the level of a tank, for instance, in a petrol tank, and also leak detection in refrigerant. So these are all the different types of sensors that we will learn in this syllabus. So let's look at how these sensors are used in real-life application. Alright, there are two types of application. The first type is called the monitoring application, and also the controlling application. Alright, so let's look at what they really are. And here is flowchart of how monitoring and controlling application work. So the first step is always that the sensors will detect value from their surrounding and then send the signals to the computer. And then this signal will be converted into analog to digital signal using the ADC converter. And this computer will analyze the data received and check it against the stored value. This is a key concept because think of stored value as the default value that a computer can accept. Therefore, if the sensor detected some unusual value, and this kind of signify to the computer that, hey, something is not wrong, something is abnormal, and you have to do something differently. Okay, and let's first look at what the monitoring system does. So we were here, step number 3. So after it check against the value in what is it stored, this new data, if this new data is outside the acceptable range, for instance, the normal temperature is 37. Let's say your temperature sensor detects a value of 38, and this value is outside of the accepted value, and if this happens, a warning signal will be sent to a screen or an alarm is activated. The microprocessor has no effect on what is being monitored. It is simply watching the process. That means it's a monitoring process. And a real-life example would be a security system. Okay, so the security system will use the following sensors, like the infrared sensors, the acoustic sensors, and also pressure sensors to measure what is happening in the surrounding. Okay, and again, like what we see in the flowchart, this data received by the sensor will be sent through an ADC to be converted to digital data. And the computer will process the digital data coming from this sensor at a given frequency. And the data is then compared with what is being stored, what is the accepted value. And if any of the incoming data value, whether it's the infrared sensor value, acoustic sensor value, or the pressure sensor value, if any of this data is outside of the acceptable range, the computer will then send a signal to the siren to sound the alarm, and also the light to start flashing, like the James Bond video. And this, the ADC will be used by a device to convert all this digital data to analog data. Okay, so as you can see in this application, the entire system is just monitoring. It's not doing anything. It's just monitoring the surrounding, and then sending signals to inform whoever that is in concern. And the last step is also important, in which the alarm will continue to sound or light continue to flash until the system is reset, which means until the user is being notified. So another type of monitoring system is monitoring of patients in the hospital. So these are all the sensors that are attached to a patient, and they basically measures temperature, heart rate, and breathing rate. And these sensors, they are all attached to a computer system. They will constantly send data back to a computer system. Again, this data will pass through an ADC, and this computer will sample the data at frequent interval. That means they take in values every once in a while, and the range of acceptable value for each parameter is then keyed into the computer, and the data is compared with what is the data received by the sensors is compared with what is in the computer. And if any of the incoming data value are outside of the acceptable range, again, the computer only sends a signal, only sends a warning. Like in this case, they sound an alarm that, oh, the patient is in danger. And last but not least, if the data is within range, the value are shown in graphical form on a screen or a digital readout. And the monitoring continues until the sensors are disconnected from the patients. It's a continuous process. And so these are the monitoring system. So let's proceed to what a controlling application does. This is different because they actually do something after it detects an unusual value. So for instance, is the control of street light. And to sense the light, we'll use a light sensor. And again, the microprocessor will sample the data every once in a while, and the data is compared to what is being stored in the memory. All right. A signal is if the data is less than what is being stored in the memory, which means the light is not as much as what we expected. A signal is sent to the microprocessor, to the street lamp, and the lamp will be switched on. And this lamp will stay switched on for 30 minutes before the sensor reading are sampled again. If the data from the sensors at this point is greater than or equal to value stored in the memory, a signal is sent from the microprocessor to the street light again, and then the street light will switch off. And again, they said for 30 minutes, The reason is because we don't want to change the street light every once in a while. What happens if there's a cloud up there covering the light, right? So we open it for 30 minutes. But in different scenarios, it just works differently. But the essence of it that I wanted you to see is that because of this sensor, the computer system is able to control what is happening, whether to turn on or to switch off the light. Okay, so that's controlling system, and this is how sensors is being used in this case. And here we have some exam questions. I don't usually do this in my video, but I do note that these questions often repeat themselves, so it's good to know how to answer this type of question. So the sensors are used with a microprocessor to count how many competitors finish the race, and explain how the sensor and microprocessor work together. It's a 6-mark question. If you were to look at the marking rubric, they always start off with, usually you can also add what types of sensor you use. It could be an infrared sensor because you are detecting how many competitors pass through a certain point, and then you can just follow the format. Okay, first you detect what is the type of sensor, and then you say the sensor sends signals to microprocessors, and the signal is converted to digital using the ADC, like what we just said in all this example, and the data is compared to stored value. If it doesn't match, counter is incremented by 1. And the only customization part is this part, where in different types of question, you might need to do different things. And in this point, since we are calculating how many competitors finish the race, we increment the counter by 1 so that we are counting the amount of people crossing the street. And last but not least, do not forget this is a 3-mark, to write that this is a continuous process. That means this application runs continuously. Okay, this is one example. I'll show you another one to show you how similar they are in terms of the answering technique. Again, here we have an automatic lightning system, and if movement is detected, light is switch on. If not, for 2 minutes the light gets switch off. And the questions are the same. If you were to look at the marking rubric, again, it's the same format. They first detect what is the type of sensor being used, okay? And then the sensors will send the data it receives to the microprocessors. The data is converted to digital data, is compared to stored value, and if it's outside of range, it will do something, otherwise it won't do anything, okay? And each time movement, it's reset. And this is only specific to this example. For different types of question, you just have to understand what are the actions that need to be taken and then write accordingly. And again, you can just end your answer by saying that the process is continuous. Okay, so that's how you answer census question. I believe these are one of the few questions that they will ask you about census. So in this video, we have go through all the different types of sensors available and how they work together to make a system. And in the next video, we are going to learn what storages is in computer, and I'll see you there. Goodbye. Alright, hello everyone, welcome to this channel again. In this video, we are going to learn about what data storage is in a computer system and what are the different types of data storage that are available in the market. So let's recap the volume architecture. So in the last video, we go through what a sensor is, which is an automatic input. And in this video, we are going to go through this part where the data is stored, like the RAM and the secondary storage such as our HDD and SSD. So this is our focus in this video. And here we have two different types of memories. The first type is the primary memory, in which they explain that internal devices used to store data that the computer can access directly. And the secondary storage is the storage that allows users to store application, data, and files. And here are some of the comparisons to help you understand the two different types of data storage in a volume architecture. Okay, so for the primary memory, it is used to store data that is key to running the computer. For instance, the code that is currently being run, the application, and also part of the OS system that needs to be taken to the RAM, so the primary memory. And as for the secondary storage, is more on storing the application data and files. And the primary memory is directly accessible by the CPU, and the secondary is not, which means that if you were to run an application or a game of software, the code for that software will need to be loaded into the RAM first before it is being run, because the CPU can only directly access what is being stored in the primary memory. And here they said RAM is all secondary storages devices are non-volatile, but for primary memory, RAM is volatile and ROM is non-volatile. Volatility is basically mean whether the data will still be there when you turn off the computer. And every storage that we are going to learn, it will be non-volatile except for RAM. Alright? And the primary memory is built internally into the computer, but the secondary storage, it can be external or internal, which means you can have a removable hard disk if you want to, but you can't have a removable RAM or ROM in your computer. And the example of primary memory is your RAM, your ROM, your cache memory, and the secondary will be your HDD SSD, and also your DVD, Blu-ray disc, etc. So let's dive deeper into what the primary memory is and some of the different types of memory that are in this category. So the first type of primary memory is the RAM, which is known as the random access memory. The meaning of the name is basically any memory location in RAM can be accessed independently of which memory location was last used. If you look at this diagram here, it's our RAM diagram. Basically, it means that if I want to access this data in location 10, the computer can just access it directly without going through the memory one by one, like how we used to check for a word in dictionary. So that's the meaning of RAM. Therefore, when you run an application or program, data is retrieved from secondary storage, like what I said. It has to be moved from secondary storage into the RAM and placed temporarily into the RAM. And some of the features of the RAM is that it can be written to or read from, and the data can be changed by the user or the computer. It is used to store data, files, part of an application, or part of the operating system currently in use. Note that we have a keyword here called part of. This means that if you were to run a game, not every code will be moved from the storage into your RAM. It's just part of it, part of those that needs to be run, alright? And it is volatile, which means memory content will be lost. Every memory here, they will be lost when you power off the computer. So that's how we call a storage volatile. The larger the size of the RAM, the faster the computer will operate, because it can take in much code, much program to be executed at the same time. And when we learn about virtual memory, you will again realize how beneficial it is to have more RAMs in your computer. And there are two different types of RAM here. First one is called the dynamic RAM, which is commonly used in our day-to-day life, something that we use in our computer. It consists of many chips, and each chip consists of millions of transistors. And the other types of RAM that we are learning here is the static RAM, which is usually located inside the CPU. They make use of flip-flops, which hold each bit memory. And for dynamic RAM, it needs to be refreshed every 15 seconds, but static, it doesn't need to be refreshed. And the advantage of dynamic RAM is that it's usually much less expensive, cheaper, and also consume less power and higher memory capacity than SRAM. And as for that, SRAM, it is a faster type of RAM. Okay, they are usually used for DRAM. They are basically used as a common RAM in our computer. And as for the SRAM, since it is very expensive, therefore it's usually used as the cache in our computer. If you remember, cache is basically a memory storage within the CPU chip to store commonly used instruction. It speeds up the computer speed. Okay, so these are everything about RAM, and let's move on to ROM, which is the read-only memory. it cannot be changed or written to. The content can only be read. That's why it's called read-only memory. And it's non-volatile, which means even though after you turn off your computer, the content will still be there. And they are that's why we call them permanent memories. They are used to store data that the computer needs to access when powering up for the first time, such as the BIOS program, okay? And these are known as startup instructions. And here are some differences between RAM and ROM. For RAM, it's temporary memory device. When you power off your device, the content will be lost. And for ROM, it's permanent, and RAM is volatile, and ROM is non-volatile, like what we said. RAM, the data can be written to or read from, and as for ROM, the data stored cannot be altered. For RAM, it's usually used to store data files, programs, part of the OS currently being in use. And as for ROM, it's used to store startup program like the BIOS. And so that's all about primary storage. So let's move on to the secondary storage. They are usually larger in size as compared to primary storage. The RAM in your computer might be 32 gigabytes, but for your secondary storage, like your hard disk, it could be up to 1 to 2 terabytes. Okay, so they are basically used to allow users to store application, and they are non-volatile. They have slower access time by the CPU. The CPU can access them, but it's not usually the case. So let's look at the first device of the secondary storage, which is the hard disk drive. All right, it is used to store data in digital format on the magnetic surface of the disk. So here we have a disk here, okay, and the player here, it can spin 7,000 times a second. So how the data is read is that it uses something called electromagnetic heads. This consists of electromagnetics that are used to read and write data to the platers. And imagine this is the disk, and the plater is like that. It will just bend, and then the magnetic heads will read data by using this. Okay. So as for the HDD, it consists of something known as the tracks and the sector. All right. So they are basically used to store data on the disk. So it could be some binary here, as you can see what I'm drawing here. Okay. A sector on a given track will contain a fixed number of bytes. So this is the sector, and this is the track. And we all know that HDD is comparatively slow as compared to SSD, and this is because to read data from this HDD, it requires a lot of read and write action. The read-write heads to constantly look for the block of data. This means that a large number of heads movement. So I will illustrate it by drawing some of the bits on HDD. Imagine we have data here and also some data here. If you were to access the first data and the second data consecutively, this means that the electromagnetic head, imagine this is the head, sorry for the bad drawing, it will have to move here and then move to here again. It will have to have multiple movement, and these effects of latency become significant when you have a lot of data to read, and latency is defined as the time it takes for specific blocks of data on a data track to rotate to read-write head. Okay, so that's what makes the HDD slow and also quite hot at times. And another term for HDD, not term, but something bad that could happen is called fragmentation, because when the data is stored on the HDD, the required number of sectors to store the data will be allocated, which means that if I were to store a value here, so data 1, 2, 3, 4, the data will be allocated a spot on the HDD to be stored, but after a while, the HDD will undergo numerous deletion and editing, which means these data stored here will be super fragmented, which means they will be stored very far away. Okay, they are split. Therefore, it will cause the CPU, it will cause the reading speed to deteriorate because the data are stored far away. And if this happens, a defragmentation software can be used to tidy up the disk sector. So what do we mean by tidy up is that this data here, so let me clear everything. it will be stored as this. Instead of the data being split to multiple sectors, they all will be placed in the first track. So that when the CPU wants to read this data, the electromagnetic heads won't have to move too much. So that fragmentation of HDD. Okay. So another types of HDD is the removable hard disk. We all know what they are. They are not stored internally in the computer, but they allow you to carry stuff away. And that's HDD. And an improved version of a hard disk drive would be the SSD, the solid state drive. The other name of it is known as the flash storage. As implied by the name, we know that it's very fast, flash. They have no moving parts, and all data is retrieved at the same rate. So what we learned in HDD just now is that different types of data will have different retrieving speeds because the data could be fragmented. But for SSD, this problem wouldn't occur. Here are some of the instruction. Data is stored as 0 and 1 in millions of tiny transistors, and these data are stored by movement of electron within the logic gates, and the electric current reaches the control gate and flow through the floating gate to be stored. A dielectric coating separates the two transistors, which allow the flowing gate transistor to retain its charge. Basically, it means that if you look at the electric source here, how they control what data to be stored in each section is they control how much electric current is flowed at that time to detect how much, what is the data being stored. Okay, I will include a link in the description that explains SSD much better than I could. Okay, but here we just need to know that they are faster, and also what are the advantages compared to SSD. So I created an acronym for this. Let me take fried chicken. L stands for lighter. They are lighter than the HDD, more reliable, thinner, faster in data access, and cooler because they don't have the moving heads. And the disadvantages is that they have poor longevity, therefore it's not used in most servers. Here we have another note here is that memory sticks, the pen drive that we use, they use solid state technology. Okay, so let's move on to the third type of secondary storage, which is the optical media. And we have the CD, DVD, and also the Blu-ray disc. And how the CD works is actually, how do they store the data 0 and 1 is via the concepts of LAN and PID. So imagine this is the surface of the CD, and the surface will contain some of, they call the LAN, which is the upper area, and also the PID. And as with a HDD, a CD is divided into sectors like this for direct access to data. And the data is stored in what they call the pits and lane. A red laser is used to read and write the data. So how they read and write the data is very interesting. So the laser beam, like this red arrow here, it will be emitted. And if it reaches the pit, it will take a longer time to be reflected back to the emitter. So this tells the computer that this is a zero in binary. And on the other hand, if the emitter reaches a LAN, the reflection time for the time for the light to be reflected will be shorter, and this tells the computer that this is a 1 instead. And when it is spun, the optical head moves to the point where the laser beam contacts with the dead surface, it emits the bright light, okay, and follow the spiral track from the central onwards. That's how a CD is being read. And the difference between CD and DVD is that DVD has more storage than CD because it can be dual layers. That means both sides of the CD can store data. Reading and writing of the second layer is done by red laser focusing on the fraction of a millimeter difference compared to the first layer. And single layer DVD still have a large storage capacity than CD because of smaller pit size. We'll talk more about this when we go through the red Blu-ray disc. Alright, so let's talk about Blu-ray disc. So the essence of Blu-ray disc is that instead of using a red color ray, a blue color ray is used instead. And the difference between the two types of rays is that the Blu-ray, it has a shorter wavelength. shorter wavelength. This means that the length and the pits, they can be more concentrated. There can be more pits and lengths in just 1 centimeter meter square. And the shorter the wavelength, what they say here is the laser light, the greater the storage capacity of the medium. And this Blu-ray disc will automatically come with secure encryption system that help prevent piracy and copyright infringement. And the data transfer for Blu-ray disc is also faster. Okay, and it can be single layer or a dual layer. And here are the disk size capacity for CD, DVD, and Blu-ray discs. It's a big difference. That's why Blu-ray discs are usually used to store high quality movies. Alright, and that's the third type of memory, which we call the optical media. We have the CD, DVD, and the Blu-ray disc. So the fourth type of memory is a little bit tricky to understand. It's called a virtual memory. It's called virtual because it's not a hardware component, but something that computer scientists use to make up of the lack of RAM storage. So part of the memory, okay, when do we need a virtual memory? The scenario is when the processors run out of memory. Imagine that you have a lot of instructions to be run. You want to run many programs at the same time, but you have only very little RAM, and that would cause the RAM to be insufficient. And here they say if the amount of available RAM exceeded due to multiple programs running, it's likely to cause a system to crash. This can be solved by using the hard disk drive or SSD if we need more memories. So what do I mean by that? Imagine that we want to run 5 instructions, but we only have 4 available slots in the RAM. Alright? In the RAM. So this means that the 5th instruction cannot be run first. But we need a place to store the instruction, right? Therefore, what virtual memory does is that we try to allocate part of the SSD or HDD, our secondary storage, to store what is supposed to be stored in the RAM. Okay, so imagine that each instruction is being mapped to a RAM already, and the one that doesn't get allocated will be stored into the HDD and SSD instead. Okay, and virtual memory now will move the oldest data out of RAM and the HDD allowed program to gain access to the RAM. In other words, they kind of swap the instruction which can use the RAM. So for instance, the instruction 0, initially it is using the RAM. For now, it is being stored to the HDD and SSD, so that instruction number 5 can use the RAM slot here. And this exchange will keep happening to make you feel like you have unlimited RAM in your computer. Alright, so that's the essence of it. I won't read this, but here's another term called disk crashing problem, which means that if what the computer does is just keep moving instruction around without doing anything, this would make your computer very slow. And this is why in our previous section we say that if you have more RAMs, that would be better because virtual memory wouldn't be needed so often. Okay, so that's the benefit of having a high storage RAM. The 5th type of storage that we will learn, the last one, is called the cloud storage. Right, a method of data storage where data is stored on remote server. That means, for instance, your Google Drive, your Dropbox. So instead of saving data on a local hard disk drive, a user can save their data in the cloud instead. Okay. So the advantages here are some of the advantages and disadvantages. And the advantages is that it can be accessed anytime. If you were to store your storage in a cloud, it can be accessed whether or not you bring your computer. And as for the disadvantage, it will be that if you don't have a good internet connection, then you wouldn't be able to access the data. And the other advantage of cloud storage is that there's no need to carry an external storage because everything is stored on the cloud. And the disadvantage is that cost can be high. And the cloud storage provides the user with remote backups of data to alleviate data loss. And the setback of cloud storage again is that what if the server goes down, and this will result in the the data not being able to be retrieved. So that's all about the storage chapter. We learned what primary memory is, secondary memory, and also optical media, virtual memory, and last but not least, cloud storage. And in the next video, we are going to talk about some of the network hardwares, and I'll see you there. Goodbye. Hello everyone, welcome back to this channel. So in this video, we are going to look into what are some of the network hardwares in the world, right? So here are the two network hardwares. First one is called the network interface card. It is needed to allow a device to connect to a network, such as the internet. We'll definitely talk more about internet in chapter 5, but in this video, we are just going to talk about what are some of the devices, hardware that's needed to allow a computer to connect to the internet. And this is one of it, the network interface card, which is usually embedded into your computer. Okay, so there are another form of network interface card which is known as the wireless network interface card. They use wireless connectivity using an antenna to connect with the internet via microwave. Okay, so let us first introduce the concept of an IP address. Okay, so an IP address is an address that is given to a router when it connects to an internet. This address is needed so that data knows where it is being sent to. Just like how you order something on the web, and address is needed to know where the item needs to be sent to. Alright, when a device connects to a private network, like when a device, your smartphone, your laptops, when it's connected to a private network, a router will assign a private IP address to it. Okay, so imagine this is the IP address of the router, and with devices connected to it, they will be given an IP address, private IP address, and this address is unique on the network, but might be the same as an IP address on a separate network. All right, so this is the format for an IP address. All right, this is for IPv4, each digit ranging from 0 to 255. If you remember what we learned in data representation, we only need 8 bits to store this data, and each digit is separated by a dot, and we'll have 4.3 billion combinations. All right, which means from 0, let me use another color, from 0, 0, 0, 0 until 255, 255. We will have in total 4.3 billion combination if you were to apply permutation to it. All right, and these value can be represented in hexadecimal too. So another format of IP address is called the IPv6. It is basically a longer version of the IP address, in which each value ranges from 0 to 65,000. It's a lot more as compared to IPv4, and each digit uses 16 bits separated by colon instead. Okay, if you want to count how many combinations, you can try to type in your calculator 65,000 to the power of 8 and see the value that you have. Okay, so in my class, I asked my students what are some of the reasons that IPv6 is needed if we already have IPv4. So here are some of the answers. It reduces the risk of IP address collisions. Imagine this, in this world there are tons of routers out there, so we don't want them to have the same address. That's why computer scientists expand IPv4 to be IPv6. And IPv6 also has some authentication check, in which it stores additional value to check whether the value is legitimate. And another thing is that IPv6 has been designed to allow the internet to grow in terms of the number of hosts and potential increase in the amount of data traffic. That's what I've been saying, because the risk of collision decreases. That means more hosts can be created. So there are two types of IP address. The first one is called the static. Static IP address are permanently assigned to a device when they by the internet service provider. They don't change each time a device logs into the internet. It's used by remote server, which are hosting a website or a online database. It's allow faster upload and download speed. Alright, so that's for static. the other one is more flexible, which is the dynamic IP address. It is assigned by the ISP each time a device logs into the internet. Alright, that means each time you are connected to the internet, you get a different IP address. Alright, the advantage of it is that they provide greater privacy since they change each time a user log in. No one can track your IP address down because it keeps changing. And here's a diagram of what happens behind the hood when we type in something into Google. So before you access the website, this device will need to go through an additional step to know, okay, what is my IP address to the DHCP server, and this server will then send a dynamic IP address back. Do note that this IP address will be different for dynamic IP address each time the user logs into the internet. Okay, and as for the static IP address, it just doesn't do the first step because for the device, it already has a fixed IP address. So that's static, the difference between dynamic and static IP address. So we know that each router will have a unique IP address, but we also know that multiple devices can be connected to this router at the same time, right? Like that. So what we are concerning here is that what if a data reaches the router following the IP address? How do we decide whether this data should go into computer A or computer B or computer C? Okay, and therefore we'll need another address to uniquely identify a device, which is called the MAC Media Access Control Device. It is used to identify a computer on a local area network. So what we have here is a local area network. They all connect to the same router, and this MAC address will be used to identify which laptop needs to receive the data. And just like IP address, they have a format here. Each digit is represented by hexadecimal, and if the NIC card is replaced, the MAC address of the device will also change. Feel free to check what is the MAC address for your device. I'm pretty sure you can get it using Google. So that's MAC address. It is used to uniquely identify a device on the local area network. And as for the router here, let's move on to the router. We'll just talk about some of the functions. The function of a router, the first one is that it enables data packets to be routed between different networks. So which means if I'm at location A and I want to send some data to location B, this data will be directed by the router back to the right place. Okay, so that's what the router does. The second function is that they take data transmitted in one format from a network, which is using a particular protocol, and converts the data back to a protocol that is understood by another network. Therefore, it allows the different computers to communicate. That's also what makes the internet work. And the third one is that since every computer on the same network has the same part of the internet address, which means each device, they have the same IP address, therefore the router is able to send data packets to the appropriate switch, and the data will be delivered to the correct device using the MAC address. That's how we identify whether this message should be sent to computer A or B. We use the MAC address. And that's all about network hardware, and it's also everything about chapter 3. I hope you learned a lot in this series of videos. That's the end of it. I'll see you in the next video. Thank you.